Today we are going to talk about performance-based wind design. This is an emerging subject, and it's fairly complex topic also compared to the wind design that we have been doing um, in our current practice. Uh, so it'll be very difficult for me to explain everything that you need to know into our seminar, but I would consider this as a good introduction. If you haven't heard about the performance-based wind design, I think you will get a pretty good background of what is involved and what are the advantages. So uh, don't expect to be expert by the end of this seminar, but I think you will know a lot more and get familiarized with the emerging topic that is coming in our industry. So with that, let's start with the learning objective for today. We are going to first start with differences between the performance-based design for wind that we are going to discuss today, and how it differs from traditional design approach. Uh, Throughout the seminar, I may use traditional design or code-based design or even elastic design. Those are all same. That's something that we have been doing for decades. And performance-based design for wind, it differs significantly from that current approach. And we'll go through the differences. Uh, then anytime you talk about the performance-based design, you have to deal with performance objectives and also the hazard for which you are dealing with. Uh, and we'll go over those also. There are three performance objectives in whenever you use performance-based wind design approach. Those are occupant comfort performance objective, operational performance objective, and continuous occupancy or limited interruption performance objective. We'll go through this three performance objectives and also go through methods that are available to evaluate these performance objectives. Um, then we'll briefly talk about ASCE SEI Prestandard that is available, and there are three methods to evaluate continuous occupancy and limited interruption performance objective. We'll cover method one. We'll briefly mention about method two and three. They are fairly advanced and we are not going to cover in this presentation. Then finally, we'll close with how you can implement this performance-based wind design approach in your project. What is the path available for consulting engineers? We'll cover those, and there is a brief mention about the project example. With that, let's start. So before we start, I want to go over the difference between the elastic design approach or traditional design approach, or what we sometimes call code-based design. So if you draw kind of a force displacement curve for lateral load resisting system in your building, it looks something like this. And we design our buildings or main wind force resisting system for design level forces. These design level forces are based on the risk category that your building belongs to. For risk category 2, for example, we would use 700-year MRI wind. Once you get the wind speed from the code, you calculate the wind pressure based on the topography and exposures and so on, and then you find out the wind loads on your building, and the static wind loads are applied on every floor or every diaphragm that you may have in your building. And then you find out the member forces, axial force, bending moment, shear forces, and so on. And then depending on the material that you have, if it is a reinforced concrete member, then you would use ACI 318. If it is a steel member, then you would AISC 360 and design those members. And the design involves a process in which you make sure that demand from this analysis is less than or equal to the design capacity. And the design capacity is nothing but phi times the nominal strength of the member. So every member in main wind force resisting system, you satisfy this strength, and therefore when the building experiences design level forces, then each of these members are also expected to not yield. So if each of these members in your frame are not expected to yield, then overall the response of the frame is also going to be below or at first significant yield.